Today we will be doing how to find out the solution of system of non-homogeneous equation. Now let us see what we mean by non-homogeneous system of equation. I will be helping you with the help of example. Let us take you have been given a equation like 2x plus 3y plus z is equal to 1, 4x plus 3y plus 5z is equal to 4, and x minus y plus 2z is equal to 0. These are just randomly I have taken the equations. Now if you look at this equation, the right side term not all zeros. That is the very important point. If all of them become 0, it becomes homogeneous system of equation. If at least one of them is not equal to 0, that means it will become non-homogeneous equation. When it comes to homogeneous equation, the right side part, this total part, all the three elements like in this example should be 0. So when it comes to homogeneous, all the right side term, that is the constant part, becomes 0. In the case of non-homogeneous, at least one of them will be non-zero. That means at least one number will be present which is not equal to 0. Now before starting the solution of this non-homogeneous equation, we will require one more concept, that is a augmented matrix. As we know, we can convert this in the matrix form as it is. It can be written as, first row will become 2, 3, 1. These are the coefficients of x, y, z respectively. The x coefficient for the second row is 4, y is 3, z is 5. Here x is 1, y is minus 1, z is 2. We will write this in the matrix form. Then we multiply the variable, that is x, y and z. And the right side we are having, that is 1, 4 and 0. This is the matrix form of the given system of homogeneous equation. Now if we take the right side to the inside, like 2, 3, 1, 4, 3, 5, 1, minus 1 and 2. And we will put here a straight lines. In some books they have given a dotted line, and in some places they are using the vertical straight line. Then the right side will come here 1, 4 and 0, and then we will complete this matrix. This matrix is called as a augmented matrix. Generally we denote this matrix first by A, the second matrix as X and the right side as B. So we get this one in the form of AX is equal to B. Now when it comes to augmented matrix, we say that is AB, like this, or AB, and we write augmented matrix. Now just we need to remember that when we take the coefficient matrix of equation and the right side, taking the right side as the last column of the matrix, separating by that by a straight line or a dotted line, we call that as a augmented matrix. So we will be using this augmented matrix while solving the system of equations. I hope you have understood the concept of augmented matrix. Every time we will be converting the given equations in the matrix form and then in the augmented matrix form. Now we will be taking one more example to explain this augmented matrix concept. Let us take a equation as a 2x plus 3y is equal to 5, 4x plus 7y is equal to 11. Then we write augmented matrix as first column, that is x values 2 and 4, second is y value, second column 3 and 7. Now we have only two variables, so next is going to be the right side, that is 5 and 11, and we separate this by a straight line. It clearly indicates that this right part is a right side of the equation. I hope you have understood. Let us take one more example. Suppose you have been given as a x plus y plus z is equal to 3, 2x plus y plus 3z is equal to 6, and 2x plus 2y plus z is equal to 5. Now sometimes what they do, in the place of taking the right side here as a constant term on the right side, they take that to the left side and make the right side as 0. So I will convert that in that format. So they can write this equation as x plus y plus z minus 3 is equal to 0, and 2x plus y plus 3z will be minus 6 is equal to 0, and 2x plus 2y plus z minus 5 is equal to 0. See here, we have the three variables from here to here. These are the constant terms. They have taken that to the left side, so you need to take it to right side to convert this equation into standard format, that is this format. Now after that we will be converting that into the augmented matrix format. Suppose you have been given the question like this, then you have to convert this into this format, and then you will be writing the augmented matrix. Augmented matrix, that is going to be, first we will write x coefficient, that is a 1, 2 and 2. Now the second is y coefficient, that is 1, 1 and 2, and z coefficient is 1, 3 and 1. Then we write the right side. What will be the right side? That is this one, that is 3, 6 and 5. This completes our augmented matrix part. I hope you have understood this one. Now we will be doing how to find out the solution of system of non-homogeneous equation. There are total 3 types in that. Now first thing we will be doing that, I will be giving you the flow chart. System of non-homogeneous equation. Now when it comes to solving this one, we are having 3 types. The first one, rank of A is equal to rank of augmented matrix, that is AB. In this case solution exists. We say that as a system of equations are consistent. Equations are consistent. Now when it comes to the second part, that is a rank of A is less than rank of augmented matrix, that is AB. In this case solution does not exist. System is not consistent. System of equations are not consistent. And solution does not exist. Now when it comes to this, it is again divided into two parts. Here rank of A is equal to the number of variables. In this case, there will be unique solution. And I will elaborate this here. Rank of A is less than number of variables. Then there is going to be infinite solution. Now we have total three cases here. The first one is this. This is the first one. Solution does not exist. That means system of equations are not consistent. In this case, rank of A will not be equal to the rank of augmented matrix. That means rank of A is going to be less than rank of augmented matrix. Now when rank of A and rank of augmented matrix are same, we are having two type in that. That means solution exists and it is unique, and here solution exists and there are infinite solutions. So these are the three ways of these are the three cases of the system of homogeneous or non-homogeneous equations. So always remember, first of all, you need to convert the given matrix into the augmented matrix, find out the rank by converting that into echelon form. Once you came to know the rank of A and rank of augmented matrix, then you can come to know these three cases. So if rank of A and rank of augmented matrix are not same, that means rank A is less than the rank of augmented matrix. In that case, solution does not exist. We say that system of equations are inconsistent or not consistent. Now when the rank of A and rank of augmented matrix are same, then there are two cases. The rank of A is equal to the number of variables given in the equation. In that case, the system will be having a single solution. We call that as a unique solution. Now when the rank of A is less than the number of variables, in that case we will be having infinite solution. So we will be doing one by one. So we will be doing first as this one, then we will be having some questions based on this, and then we will be having the third type, that is this one. So when it comes to the homogeneous system of equation, we will be doing that afterward. Let us take an example of the case 1, that is a case 1, that is where system of equation is inconsistent and the solution does not exist. Let us take an example. Solve the equations. The first equation is 2x plus 6y is equal to minus 11. 6x plus 20y minus 6z is equal to minus 3, and 6y minus 18z is equal to minus 1. Now here if we look at this one, in the first equation z variable is not given. In the third equation x variable is not given. That means those corresponding coefficients are 0. So we will write this in augmented matrix format. Now let us see what is going to be the augmented matrix. Now we will be taking the first equation, the x coefficient 2, 6. In third equation x is not given, that means its corresponding coefficient is 0. Now we will be doing the second one, that is y variable. The first equation here, this is y, So 6, 20 and 6. 6, 20 and 6. Now when it comes to z variable in the first equation, z is not given, so we will be taking as 0. From second it is minus 6, and from third it is minus 18. Then we will be putting the vertical line, and we will be copying the right side, that is minus 11, minus 3 and minus 1. This is our augmented matrix for the given system of equations. Now we will be converting this into echelon form to check what is going to be the rank of this matrix. Now this is 2. This is 6. We know if we multiply this 2 by 3, it becomes 6, and if we subtract with this 6, it will become 0. So our operation is going to be R2 minus 3 times of R1. Now we are changing R2, so R1 and R3 will remain same, so we will copy paste that. That is 2, 6, 0, minus 11, 0, 6, minus 18, minus 1, and here is the vertical line of the augmented matrix. Now we will be having the rough part. Now let us see that operation is R2 minus 2 times of R1. We will be writing the R2 elements. R2 elements are 6, 20, minus 6, minus 3. And it is 3 times of R1. So 3 times of R1 will be we will be multiplying this row number 1, that is we can take this one, this R2 by R1 by 3. So 3 2s are 6, and 3 6s are 18, 3 zeros are 0, and 3 into 11 with the minus sign is going to be minus 33. We are going to subtract this one, sign will change, this will become 0, 20 minus 18 is 2, 6 minus 0 will remain minus 6, and minus 3 plus 33 will become 30. So we got the answer for this, that is 0, 2, minus 6 and 30. Now the next thing is to convert this element as 0, because to convert matrix into echelon form, we need to convert this in the upper triangular matrix format, that is below the diagonal need to be, all the element below the diagonal need to be 0. Now here we are having the corresponding diagonal element as 2. With the help of this 2, we are going to make this as 0. So this is 6, this is 2, so we will be multiplying row number 2 by 3. So it is R3 minus 3 times of R2. This time we are changing row number 3. So row number 1 and 2 will remain same. So we will copy paste that. The row number 1 is 2, 6, 0, minus 11. And row number 2 is now 0, 2, minus 6 and 30. Now we will be doing here the rough work for this calculation. Operation is R3 minus 3 times of R2. R3 elements we will write first, that is from here it is going to be 0, 6, minus 18, minus 1, and 3 times of R2, that will become, we will be multiplying this by 3. So it is going to be 0 into 3 is 0, 2 into 3 is 6, and minus 6 into 3 is minus 18, and that is, this one is 30, 30 into 3 will become 90. Now we will subtract, sign will change, this is going to be 0, this is going to be 0, 18 minus 18 plus 18 will become 0, and minus 1 and minus 90 becomes minus 91. Now we will write that 0, 0, 0 and minus 91. Now if we look at this matrix, we have this in the upper triangular matrix format, that is echelon form here we got. Now from this, if we predict the rank of this A matrix, how many rows are 0? Row number 1 is non-zero, row number 2 is non-zero, but row number 3 is 0. So rank of A is equal to 2. Now if we take full matrix, that is augmented matrix, if we take all the elements together, that is augmented matrix. The first row is non-zero, R1 is not equal to 0, R2 not equal to 0, and R3, if you look at these three elements are 0, but this last element is not 0. So R3 will also be non-zero row. That means the rank of augmented matrix, that is AB, that is, we call this here, we can put dot here, AB, that is equal to 3. The rank of A and augmented matrix are not same. Therefore, since rank of A is not equal to rank of augmented matrix, therefore given system of equation are inconsistent. Therefore, solution does not exist. I hope you have understood this one. Always remember, you have to convert the given equation into the standard format. That means if anything is given on the left and the constant term is given on the left side, take it to the right side, and then convert that equation in the augmented matrix form, apply the row operation, convert the matrix into the echelon form, and then you predict what is the rank of A and what is the rank of the augmented matrix, that is AB, taking all the together terms. Then if their ranks are not same, that means given system of equations are inconsistent, and in that case solution will not exist. Now the main thing, what do you mean by inconsistent? Inconsistent equations means they are not having any common solution. Whenever we are given a system of equation, that means 2 equations, 3 equations together, and they are saying find the solution, that means we are going to find a solution which is applicable to all the equations. In that case, we say that the equations are consistent, and if we are not able to find out a common solution which satisfies all the equations, then we say that the given system of equations are inconsistent. So here inconsistent is a single word, this one. Inconsistent means there is no common solution to the given system of equation. I hope you have understood this one. Next time we will be having a few more sums on the non-homogeneous system of equations. We are yet left with the two type, that is type number 2 and type number 3. We will be doing that in the next lecture.